Hi everyone, welcome to AMU 1018 Week 7. Today we're talking quantitative data analysis. Previously, we looked at this topic from the end product, and thus it might have seemed a little bit intimidating and complex because you're looking at the finished journal articles and all the processes, all the statistical, regressions and correlations that the researchers use, and you're thinking, how am I going to do this? It's just so complex. Well, it isn't really. Behind every complex idea is a simple, basic idea that you go, oh, that's all? That's what it is? That's what we're looking at today. We're going to look at the building blocks and the foundations, a couple of basic ideas. So we're going to look at the basics, and then we're going to look beyond the basics. We're going to look at creativity in data analysis, not only from quantitative research, but all kinds of research, including big data. Do you know what's the biggest mistake when it comes to planning survey research? According to Bryman 2012, students often think, I don't have to concern myself with how I'm going to analyze my survey data until after I've collected my data. I'll leave thinking about it until then because it doesn't impinge on how I collect my data. Wrong! According to Bryman, you cannot just apply any technique to any variable. Techniques have to be appropriately matched to the types of variables you have created through your research. This means that you must be fully conversant with the ways in which different types of variables are classified. The size and nature of your sample are likely to impose limitations on the kinds of techniques you can use. So let's start with your research question. You want to answer that question, right? You want to discover the relationship between the variables that you have identified. It's very, 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 very important to think about the entire process. Then, from your question and the data collection, you need to draw a line and a connection, and that connection is the data analysis. In order to get from your survey to answering your research question, you need to consider the type of data you're collecting and how you're going to analyze it. If not, you will have your research question on one hand, you'll have your survey on the other hand, and you just don't know how to bring these together. You don't know what really answers your question. Data analysis and the simple concepts behind that are the key. So rule number 1 is make data analysis part of your plan and part of your survey or your research project design.
The reason why we're looking at data analysis now as you develop your survey and your research proposal is again because your survey questions will result in the type of data that you receive, and the type of data that you receive will determine whether or not you actually answer the research question that you seek to answer. So a good way of designing your survey is to go from the research question to the type of data that you want to get, and finally, what kinds of survey questions would you ask to lead to these to the analysis and to the research question. It's very much related, so you need a very clear and well-defined plan for assignment 2.
We are going to look at 3 very simple concepts today, and the first concept is how many variables will you be looking at a time. Different types of questions produce different types of data in 3 categories of analysis: univariate, bivariate, and multivariate. Basically, are you looking at one section of data, one variable at a time? For example, somebody's age, somebody's gender, what course you're studying. You're looking at these things one at a time, and then you will analyze this data one at a time. Then we have something a little bit more complicated. You're going to look at two variables and how they interact with each other. And you will be putting two variables together. And finally, there is a very, very complex, but it really builds on the same concept, and that's multivariate analysis. So are you looking at one, two, or many variables with that particular aspect or angle of analysis? Are you looking at someone's age, for example? Are you comparing someone's age with the diet that they have or their use of social media? And you're comparing two things. And multivariate analysis is comparing multiple things to try and find patterns in that data. Before we look at one, two, or many variables in our analysis, that is uni, bi, and multivariate analysis, we want to talk about what types of variables there are. So let's start with a very simple one. Dichotomous variables are simply questions to which there are only two answers, such as yes or no. Are you a Monash University student? Yes or no. That's a dichotomous variable. Secondly, we have categorical variables. These don't have any particular order. These can just be a range of things, such as a range of sports. You might ask participants to select which sport they engage in on a weekly basis from a list of different sports. Swimming, kayaking, ping pong, tennis, whatever sport they engage in. These are categories. These are names. Swimming doesn't come before kayaking. You can put kayaking before swimming. It really doesn't make a difference. Or asking someone to pick their favorite color. Black, blue, red, yellow. There's no set order to these, and therefore these are called nominal or categorical variables. Thirdly, ordinal variables are variables that come in a specific order but aren't necessarily a fixed distance apart. For example, you could ask someone if they do something every week, twice a week, at least once a day. Now, these last two types of variables are similar and yet different. There are multiple options to these types of questions. For example, ranging from strongly agree to strongly disagree. This is called Likert scale. And there actually is some debate whether a Likert scale is an ordinal variable or an interval variable. And some people would say it's an interval variable whereby you have 1, strongly agree, 2, agree, next, slightly agree, and the difference between these are always the same. There's always the same ratio. Something like age could be an interval ratio where you ask someone, are you age 19, 20, 21, or 22? There is a fixed gap between each of these variables, which means that these variables are one after another. They have a relationship to each other. Ordinal variables are a list of variables that come one after another but aren't necessarily at fixed intervals apart. So they're not interval or ratio variables, they're ordinal variables. And for example, asking someone if they brush their teeth every day, twice a day, or more than 5 times a day, whatever, these don't exactly relate to each other. They're not the same interval apart, but they do come in specific order from most to least. And some people would say that Likert scales are ordinal variables. I tend to think that they are interval variables, where there is a kind of fixed distance between each of the answer options.
In terms of dichotomous variables, questions with only 2 responses, you can code them as 0 and 1 or as 1 and 2. If you were to use a program like SPSS, which we are not using in this unit, you would basically be just like 0, 1, 0, 1, or 1 and 2 and 1 and 2. For example, you're currently an undergraduate student at Monash University, and then we have different random responses, 1 being yes, 0 being no. That's how simple it is, really. Now you might have multiple categorical options for your participants to choose from. Categorical variables have no order, but you're going to need to assign them numbers such as 1, 2, 3, and 4, such as 1 chocolate, 2 vanilla, 3 strawberry, 4 other. For these, you'll simply compare the results side by side, such as using a bar or column graph. Interval variables go from one end of the scale to another end, such as how many scoops of ice cream, 1, 2, 3, and 4. There's a fixed difference between 1 and 2 and 2 and 3 and 3 and 4 scoops of ice cream. You really have more options for bivariate analyses with these. Instead of asking participants if they have ice cream 1, 2, 3, 4, 5, 6, or 7 times a week, we could simply combine some of these categories. And when you combine these categories, the categories don't have a fixed ratio between them, but they're nevertheless in an order from least to greatest, for example. So these are ordinal variables and they're coded very similarly, just 1, 2, 3, 4, and so forth. Univariate analysis is simply examining one variable at a time, that is, basically one question at a time and the data that you get from that one question. It can be really simple, so we're going to look at these, and I think once you have a look at these, you'll know exactly what they are. Now, many of these charts are more appropriate for a research paper than for an infographic, because simply you don't want to bore people with what looks like an essay or a journal article in a poster. But let's have a look at the concept behind these, and you can translate them to something a little bit more interesting or social media friendly when you do your final infographic. So let's look at a frequency table. A frequency table simply looks at the choices for each of the options. So let's say age 20 and under, 21 to 30, 31 to 40, and so forth. You have these different categories, and by the way, these are not interval or ratio variables. These are ordinal variables, because 20 and under doesn't have a fixed relationship with 21 to 30 or 31 to 40, for example. You're grouping these together and thus they become ordinal variables. Now, if you were to look at the second column, you see n, and n is the total number of people who responded to each of these categories, and the percentage is simply the percentage out of 100. So you're looking at the total number and the percentage, and sometimes a percentage would tell you a lot, sometimes a number would tell you a lot, sometimes you choose to mention one, sometimes you choose to mention the other, or both. It really depends on how you want to discuss and present your findings. A table like this can provide a lot of information at a glance to enhance the discussion and the conclusions that you draw in the discussion of results. On the left, we have nominal or categorical variables, and on the right, we have ordinal variables. And the difference between a bar chart and a histogram is that the bar chart separates these different variables because they're just totally different categories, and the histogram shows an ordinal relationship going from the first one to the second one, third one, and there's a kind of relationship between them, so they are put close together to show that relationship. Something to note is that all the categories of your pie chart should always add up to 100%. If you have a question where participants can select multiple options, then you should be perhaps using a bar chart, because a bar chart you can show percentages in relation to the total individually out of the total, instead of in relation to each other adding up to 100%. So for example, you have the human losses of World War II by country, and these are individual as of the percentage of each country's population and also in millions, but they're not related to each other. With some questions, such as a Likert scale from strongly agree to strongly disagree, you can measure the mean, that is, all the responses added together divided by the total number of responses. So for example, you might find that the average response is 3 on a scale from 1 to 7, strongly agree to strongly disagree. Sometimes the central tendency in a range of, say, ordinal interval variables can tell you a lot. Now, if there are outliers in the data, it might be more helpful to look at the median response, because each response is only given an equal weighting, and all the responses are lined up, the middle response is selected. The mode is the most frequent value, and this can be useful as well. However, if you're simply looking at the mean or average, you don't really know the entire range of participants' responses. Perhaps they all were around, for example, 3 to 4, or they might have ranged all the way from 1 to 7. We don't really know. And that's why we need to show the measure of dispersion, if it is significant, if there is a small measure of dispersion or a large measure of dispersion. For example, the range could show that participants all spend between 48 to 60 minutes on the treadmill at the gym, and that represents all of participants' responses, and maybe the average number was 52. Now, I don't recommend using the standard deviation chart for a general poster or infographic aimed at a general audience, but it's helpful to understand the level of detail available in a standard deviation chart. Standard deviations are essentially the average amount of variation around the mean. Although the calculation is somewhat more complicated than this, the standard deviation is calculated by taking the difference between each value in a distribution and the mean, and then dividing the total of the differences by the number of values, according to Breiman 2012. Now let's look at this standard deviation chart here in detail. The box represents 50% of the respondents, and then we have the lower limits represented by one line extending from the box, and the other line extending above would be the upper limit. And then we also have the median response, which kind of shows you the slight difference between the mean, which would be at the exact middle of the box, and the median, which is a little bit towards the bottom. And then of course you have an outlier whose data is not quite as relevant and which could skew the results statistically speaking. Of course, you do not need to show each and every aspect of each and every question. Even if you were writing a detailed journal article paper, you will have to choose which pieces of information are relevant. You might have to just really pick out, for example, 99% of the participants strongly agree, and therefore you do not need to discuss the 1% that were not as relevant. Or if the data was very varied, perhaps you could show something else. But you do not need to show the full range of mean and standard deviation and every single thing for every single question. It's up to you to really choose what fits your research question, what is the general gist of your research. But moving on, let's talk about bivariate analysis, which I hope you will engage in for assignment 2. So bivariate analysis looks at two different questions and compares the results from those questions to see if there is a relationship between the two variables considered. However, you're really looking at variables, not cause and effect, because as the common saying goes, correlation does not equal causation. So we'll be looking at a couple of these types of correlation, regression, and all that in the next few slides. you might want to present this data about the relationships between these variables in your assignment 3 infographic, but I don't recommend that you use extremely complex statistical graphs and so forth. You want to keep things relevant to a general untrained audience. A very, very simple way of presenting and comparing the results from two different questions, that is, two different variables, would be to use a contingency table, very similar to a frequency table, except here you have these on the left, the different categories, and then you have the top row, which are again two different categories. Now you're comparing, in this example, the relationship between gender, male and female on top, and then on the left column we have reasons for visiting the gym. And then when you put all of these out on the table, you can examine relationships between gender and the reasons people visit the gym in a simple and straightforward manner without too much complication. This allows you to compare categorical variables, because for linear regression, Pearson's coefficient and so forth, you won't be able to compare different categories such as different types of sports or different reasons for visiting the gym. You can't compare those. It isn't a scale from 1 to 7. These are simply different types of things, and therefore you can use a contingency table like this to examine relationships. What happens if both the variables or both the questions you're looking at are interval or ratio variables? Well, then you can compare them on a scatter graph, and then you can determine the relationship between variable 1 and variable 2 and summarize that in one simple number. Is there a strong relationship between, for example, if you have lower numbers on one, will you have lower numbers on the other? If there's a strong and clear relationship on the scatter diagram shown here in figure 15.7, then you will have a number such as 1. However, if there's no relationship, the number would probably be 0. So the coefficient, Pearson's coefficient, is a number from 0 to 1. So 0 means no relationship, 1 meaning a strong relationship. And these can be positive or negative relationships. If you look at the next slide, what you have in figure 15.8 is a perfect negative relationship, that is 0.1. And really the entire scatter diagram can be summarized in one simple number that is called Pearson's coefficient. Then we have linear regression. What's the difference between Pearson's coefficient and linear regression? Well, linear regression is simply drawing a line to show if you have x, how much would y be? And thus it is quite simple as well, but instead of being one number like correlation such as minus 0.82, you have x certain number, y a certain number, that shows you a straight line, that draws a straight line through the scatter diagram. To put it very simply, essentially, yes, you are comparing the same thing. For example, skin cancer mortality versus state latitude, that is your distance from the equator. And you're looking at the same comparison of the same two variables, but how you presented what you're looking at is different. The correlation number is simply one number that tells you the strength of the correlation, and the other one is a number that tells you the line, the x and the y, if you studied statistics in school before. Now we have other types of analyses, but they're basically very, very similar. The concept is very simple. Spearman's rule is designated for the use of pairs of ordinal variables, that is, categories in a specific order but not with a specific ratio apart. Now it's exactly the same as Pearson's. However, it's simply because one variable is ordinal and the other is an interval or ratio variable. However, you will still end up with a positive or negative number between 0 and 1. And then if you're comparing two categories of dichotomous variables, you're also going to end up with a number between 0 and 1, and it's called the phi coefficient. Again, I wouldn't worry too much about it because it is the same concept. It's simply the type of variable that changes. Finally, I'd just like to explain the difference between descriptive and inferential analyses. So are you describing your findings about your sample, or are you making further inferences, drawing conclusions from data you do not have, such as by generalizing the results to a larger population? Inferential statistics, according to Babbie 2012, are used to estimate the generalizability of findings arrived at through the analysis of a sample to a larger population from which the sample has been selected. Some inferential statistics estimate the single variable characteristics of the population. Others, tests of statistical significance, estimate the relationships between variables in the population itself. For example, looking at figure 16.4 from Babbie 2012, what we have is a representative sample of women and men and people who favor equality and people who oppose equality. Alright, so in conclusion, we have looked at types of variables, numbers of variables analyzed at one time, and the type of analysis, and most quantitative data analysis would relate to these three categories. I've highlighted in red or pink the categories that we will not be engaging with for assignment 3 or assignment 2. You can of course choose to engage with these, but it's going to require a lot of complex statistics, and for that I don't really recommend it for this particular project. So starting from the top, we've looked at 4 different types of variables that result from these different types of questions that you can ask, whether it's dichotomous, a question with 2 answers, nominal, a question with different categories that participants choose from, or ordinal and interval variables which relate to scales from, for example, 1 to 4 or 1 to 7. Then we looked at analyzing 1 variable at a time, 2 variables at a time, or we didn't really look at this because it's not so relevant and it's rather too complex for this unit, which is multivariate analysis. And hopefully for assignment 3, based on your assignment 2 questions, you will be able to look at the relationships between different variables using bivariate analysis in a very simple way, such as looking at linear regression, if there is any in your results, or perhaps the coefficient, Pearson's coefficient. So, or keep things really simple, use a contingency table. Finally, what we are doing is descriptive analysis. We will not be doing inferential analysis because starting from the beginning of our design, we're not using representative sampling anyway.